Okay, so we just started a quick revision of atomic structure chapter. So today we are going with the shapes of orbitals. So before we start, it's like we have four shells. It's like nucleus one, two, three, and four. What exactly we need to know right now? So it's like the main four. So we just write the first is S, second would be S and P would be added, and third it would be S P D, and in fourth it would be S P D F. So these four are the subshells we need to remember. So here's detail of all these, and even before we start that, basic information about what is orbitals. So orbitals is like a region or a space around the nucleus, like this is the nucleus, so space around the nucleus where we can, like, the finding of electron is maximum. That space or surface is called as orbitals. And that each orbital is like, they all are not same, they all have different size. You can see it's like a near to the nucleus, so this might be smaller in size. The second one would be a little larger, then more larger. It's like the size even depends. They are different, all orbitals are different from each other. They associate with particular size can be very shape and oriented around, they all are oriented around the nucleus. So I'm sure it's clear. So let's go with the first shape, which is S. So S is like, this is spherical in shape, as I just told you, is I made. So this is spherical in shape and they are represented by a circle, and they are higher the value of n for subshell, they have the highest value, the greater will be its size. If the value of n is the number of shells, if number of shells would be greater, so the size would also be increased. And this is here in this S orbital. S tells about the sharpness, S represents sharpness, okay. And they are like, and in this region the probability of finding electron would be like uniformly distributed. We can find the value of equally to all points. And this is orientation in space with the magnetic field, because it spreads over all three axes currently. And example is like 2s is larger in size than 1s. Of course, even number can tell. S is this the circle, 2s would be for sure larger than the 1s if you have two that orbitals. So yes, this is about s orbitals. Whereas if we discuss about nodal space or nodal plane, what is that? It is only like the probability. Here you can see these are the nodes. So the probability of finding electron would be zero. Where it would be zero between these two orbitals, okay. And that plane where like probability is zero to find electron, that plane is called as nodal plane or space, nodal surface, okay. I'm sure it's clear. And when in s orbital, it has no nodal plane, we can also write, because no nodal plane or no nodal surface. Then we have about shapes of p orbital. So p orbital, it's simply like wherever you see x, y and z, this means we can identify this is the p orbital, because in this orbital they have two lobes which are in dumbbell shape. Dumbbell shape is like, you might have seen in gym if you go or something like that. So these are the dumbbell shape structure. And in xyz will represent, and if this is p orbital, so we do write it like these are represented by px, py, pz, okay. So you can also see, and it will be, and these are dumbbell shape orbitals, space around three mutually perpendicular dumbbells. So these are also perpendicular, they have equal distance between all, and they degenerate orbitals and they have equal energy. So it's also like xyz is the plane, sorry, x would be here, y z plane. So they all are perpendicular to each other, and they have same energy for all. And we also represented by px, py and pz. You can see this picture, it's like 2px orbital, 2py orbital, 2pz orbital. So I'm sure it's clear. Now let's read this. Each p orbital has two lobes in dumbbell shape. As I just told you, they have two lobes. It's like dumbbell shape is this one. No matter if you have three axes or three, yes, axis, still they will have two dumbbell shape, and lobes are either oriented in x-axis, y-axis, z-axis. X means px, y means py, z means pz, and size of p orbital increase with increase its n value. And yes, this value will be increased if we increase the n value. Okay, so I'm sure it's clear. Now we have the third one, which is shape of d orbitals. So what does this tell? D shell is like divided into 5 orbitals. They are divided into 5 orbitals. So as I just told you, this is dumbbell shape, it will be only in two lobes, right? So here they are double, so this means 1 2 and 3 4, like 4 dumbbells would be present in this picture, right? You can even see. So there are 5 orbitals, and they are under the influence of magnetic fields, and they are represented like d x y, then d x z. It's like you need to complete the axis of x, y and z. So it's like first this x would be with this one, y x would be with this z, then d, then this x would be with this xy, xy, xz, then this is dxy, and now this y would be with this z, so dyz, and again it would be like d x square y square means 2, so I'm writing d x square y square, and z would be dz square. Okay, so these 5 are the shapes. So let's read this one, and they are like dumbbell like shapes. D orbital has 4 lobes, as I just told, because you can see the shape 1, and here would be the second shape, 2 shapes. There are 4 lobes of 2 dumbbell shape in sausage shape. Sausage is like same like a mitochondria, or even you might have eaten. So they're like that shape, and these lobes are oriented along x-axis, y-axis, and z-axis. The size of d orbital increase with increase in number of course the size would be increased when we will increase its orbitals. So I'm sure it's clear. Then we have f orbital. I don't know where that's SPD. Wait, SPD. I don't know if I've written something where. Let me check that. And just like f orbital is not very important, but I can give you a little information about that. Just that's not written in this book, but still it's part of our syllabus. It's like it's very easy. This orbit exists in 7 direction. 7 direction. How? This means one dumbbell shape, two dumbbell shape, and one more would be added. So this means they have 7 orbitals and 6 lobes, and they are placed. They have 7 direction, and they are placed in magnetic field. And you can like add dxy, these kind of shapes would be there. So I'm sure it's clear. We don't have much more about this orbital, whereas this was all about the shapes of orbital s, p, d, and f, and nodal plane, nodal surface. So I'm sure it's clear to you. Thank you for watching. Bye bye.